Hello viewers, I am Dr. KSR Radhika, working as Associate Professor in the Department of Computer Science and Engineering, SRKR Engineering College, Bhimavaram, Andhra Pradesh. In this session, I am going to explain about semaphores. In the previous session, already we have seen the RTOS, task data, and how we are facing the problem of shared data whenever the RTOS switches between the tasks. So now we will see how we can solve the shared data problem using the semaphores. The objectives of today's session are to know about semaphores, to explore the binary semaphores, to understand solutions of shared data problem. First of all, we will see what is meant by a semaphore. So whenever we are using the different tasks in our RTOS system. So the microprocessor switches from task to task and like interrupts, changing the flow of execution. So we get the problem of shared data. So how we can solve the shared data problem? So we will go to the ancient methods of our railway system. So if you observe in the ancient days of railway systems, you can see the word has come from the railway system, that is from the railway signals, that is called as semaphore. So if you see in this diagram, suppose if you see in this diagram, the train is in between these two. So these poles, the poles between the poles on the either side of this train, if you see here, so these are called as semaphores. Suppose you can see a lever here. So suppose if this lever is down means, so we say that, so here in the ancient railway systems, so the signal will be either up or it will be lowered. So this means lower and this means up. So if it is lower means it indicates that the train should not enter into this section. So this is some critical section. So the train should not enter into the section means, so already some another train is there in this section. It indicates like that. So suppose if it is raised means it indicates that you can enter into this section means there is no train in this section. So when it is up means the train can enter into this section. So this is the meaning of semaphores in the railways. So railway signals called as semaphores. So for example, if you see here, so because this train is in this section, so that's why this semaphore is lowered. So that's why suppose if another train arrives here also, because this is lowered, this train should not enter into the section. So by seeing this signal, just it will stop here. And once this train ends this section, and that means here this is up, so that's why it can enter into the next section. So because it is raised, so now this train will get into this section. So once this train gets into this section, again this semaphore will be lowered because now the train is in this section. So that's why this semaphore will be lowered. So now once the train goes out of this section, so that is it has went out of this section. So once it is out of this section, this semaphore will be raised now. So once this semaphore is raised, now again this second train will enter into this section. So this is the procedure that is followed in your railways. So the same concept has been taken in our applications also. So semaphores, so that means what here we are providing we are taking care that only one train is there in that particular section. So we are using the same concept, that is the semaphore, because this section has to be shared by different trains. So but that section can be used by only one train at a time. So that's why the semaphore concept has been erased. So the semaphores are one way of protecting the shared variables. The same concept is used in our RTOS also. So the name has been arrived from railroad days when they were used to share the segment of rail between more than one rail. So that's why the same word has been taken here also. So we call it as RTOS semaphores. So RTOS semaphores, the RTOS have more than one kind of semaphores also. So, so here first of all we are going to see about RTO. So whenever we say the semaphores, in the case of rail, it is called as here we have two different signals. One is called as raise and another one is called as lower. So the same words can be used, or also other alternative words are also used as raise and lower, get and give, take and release, pend and post, P and V, wait and signal. So different vendors will be using different names. So but the name is different, but the task that is doing is same. So you can use any of these names for the semaphores. So first of all, we will see about binary semaphore. Binary semaphore means here it will have only two signals. So it will have only two signals, that is get and give, that's all. So similar to, this is almost similar to your rail semaphore. So here you will have take semaphore and release semaphore. If a task has called the take semaphore to take the semaphore, then any other task calling it will block until the semaphore is released by release semaphore. So this is the thing that is used in the RTOS. So only one task can have the semaphore at a time. So that is called as binary semaphore. So here you will have only two signals. One is take semaphore and another one is release semaphore. So this is what is meant by a semaphore. So now we will see how the semaphores protect the data. So already in the previous example, in the previous session, we have seen the example underground tank monitoring system where the shared data, where the two different tasks are using the shared data. So once it is using the shared data, how we are getting the value? So the same example has been taken here. So here it is in the we calculate tank levels. It is calculating the tank level. So in the underground tank monitoring system, you will have different tanks, and these tanks, you will have the flow, you will be calculating the float level in the tank. So for example, if you want to calculate the tank level in I, so you have to calculate the tank level, and that should be updated in tank data I. That is I tank level. And also you should specify at what time this tank level has been read. So these two are the variables of this tank data. So this tank data is a structure that is global. So global means that means this is saved in the fixed location in your memory. So that means what? This tank data can be shared by, your different tasks in your application. So here in the underground tank monitoring system, so we have two different tasks. One is we calculate tank level and another one is we respond to button task. So this task, what it is doing, it is calculating the tank level at some particular time. And what this we respond to button task, what it will do is, once the user presses the button, so once the user presses the button means the user want to know what is the tank level at some particular time. That is at the current time. At the current time, he wants what is the tank level. So because once the user wants what is the tank level, so this is given as high priority. And this will be continuously calculating the tank level. So that's why this is given the low priority task. So for example, suppose if you see here in the we respond to button task, so if the user pushes a button, so you will get the button ID, and then immediately here he has to print the data, that is the time updated and also the tank level. So but suppose if everything happens right, so that means after this task is called, after this task is called, so then we don't have any problem. But in the previous session we have seen that suppose at time t1, so already you have measured the tank level, the level is L1. So at time t1 the level is L1. So now again it is calculating the tank level at time t2. So now at time t2, the level is, for example, L2. So that means what? At time t1, the level is L1, and at time t2, the level is L2. So now suppose after setting the value, that is the time updated. So the time updated has been updated to T2. But once completing this instruction, suppose correctly after completing this instruction, suppose if the user presses the button. So because this is low priority task and the button task is the high priority task, so automatically what happens? This low priority task will be suspended at this point, that is after the time updated, and the control will be given to the button task. So now the control has come here. But what happened here? So the time updated has been updated to T2, but the tank level has not yet been updated to L2. So that means what? The tank update time updated is latest one, that is T2. But the tank level is the previous one, that is L1. So that means which are wrong values. So these are the two values in this tank data. So now once the user presses the button, the control comes here, and what happens? It will print the two values. If it prints the two values, the time will be T2, but the tank level will be L1. So which is wrong. So that's why, so in order, so because this problem has been erased, because here you are using the tank data variable that is shared by both the tasks. These two tasks, this tank data variable is shared by these two tasks. So that's why we got the problem of shared data. So how we can protect the data is, so you can use the semaphore concept. So while setting these two values, before that what we will do is, here we will take the semaphore. So that's why take semaphore off. So once the semaphore is holded by this task, so now set tank data of I dot time updated. The time is updated. So after this, what happens? Now the user presses the button. So even though the user presses the button, what happens is immediately this will stop and the control will come here. So once the control has come here also, what happens is, so these statements will be executed. That is, the button ID will be collected. All those things will be happened. So now again here you have given the take semaphore. So you have only one semaphore. This semaphore is already with the calculate tank level task. So that's why. So now it wants the semaphore. Until this task releases the semaphore, this cannot get the semaphore. So then what happens? So this task will be blocked. So at this point, that is at take semaphore, this task will be blocked. So then what happens? Again, the control comes back to this, we calculate tank level. So this statement has been already executed. That is, time has already been updated to T2. So now the other one is, that is the tank level. The tank level will also be updated to L2, and then it will release the semaphore. Once the semaphore is released, so again, now this is already blocked for semaphore. So once this releases the semaphore, immediately the control will come here, because this is again high priority task. So again the control comes to the we respond to button task. So, and this semaphore, whatever semaphore this has been released, this semaphore will be taken by the we respond to button task. So now this task will take the semaphore, and now it will print the data. So because here already the time is updated to T2 and also the tank level is updated to L2. So what will be the values that will be printed here? The T2 and L2, which are correct values. So those two values will be printed, and then you will release the semaphore. So that means what? By using the semaphore concept, the shared data problem has been solved. That is, we are protecting the data with the semaphores. So this that is here we have shown how we can protect the data using semaphores in the underground tank monitoring system. So this is the execution flow, whatever I have explained in the previous slide. So how the execution flows with the semaphores. So this is the code for we calculate task levels, and this is the code for we respond to button task. So first, this tank level task is calculating the tank level. So once take semaphore. So now what happened? The set tank data of I dot time is updated. So I told that immediately after this statement, the button has been pressed by the user. So the user pushes a button because this is high priority task. So what happens? So this before that, what is happening to this we respond to button task? It is blocked because it is waiting for the user to press the button. Until the user presses the button, it will be in the blocked state only. So that's why the button task is blocked, waiting for the button. So once the user presses the button, what happens? So from here, immediately control comes to this button task. So now what happens? So after coming to this button task, it will read the ID and then it will try to execute this take semaphore. So when it tries to execute this take semaphore statement, it cannot execute that because the semaphore is already holded by this we calculate tank level task. So that's why what happened? Again, now because this cannot be done, so that's why again semaphore is not available here. So that's why again this task will be blocked and again RTOS switches to this task. So now again already it has updated the time. Now it will update the tank level and then it will release the semaphore. Once it has released the semaphore, even though there is some another instructions to be executed in this task. So, but even though there are other instructions also, once the semaphore is released, so this is low priority task. So, and this is high priority task that is waiting for the semaphore. So, once the semaphore is released, so immediately this task will unblock and again the RTOS switches to this button task. So, now after coming to this button task, it will print the time and the tank level, and after that it will release the semaphore. Once it has released the semaphore, again this task will be blocked. So until again the user presses the button. So because this is blocked, again the RTOS switches back to the V tank levels task and it resumes after the statement release semaphore statement instruction. So it will continue with the code after this instruction. So this is how the execution flows with semaphores in the example underground tank monitoring system. So like this we can solve the shared data problem using semaphores. So this is another example how you can initialize the semaphores in the nuclear reactor application. So for example, if you see here the task priorities in the case of nuclear reactor, so we will be measuring the temperature at two different points. So always, so that means what here we will have two different tasks. One is called as read temperatures task and another one is called as control task. So this read temperatures task is, it will measure the temperatures at two different points. And what this V control task will do is, it will check whether those two temperatures are equal or not at each and every time. So it will be continuously monitoring the temperatures whether these two temperatures are equal or not. So because this is the shared data, so these temperatures of 0, temperatures of 1, this is used. Suppose if you see here static int I temperatures of 2. So this is given as static integer as global. So if it is given as global means what? It is stored at some fixed location in your memory. So at some fixed location in your memory means this variable can be used by the different task of your RTOS. So here we have two different tasks. So these two tasks are using this high temperatures task. So here also, suppose if the temperatures at some particular time it is 70 and 70. So whenever you are suppose and here this reading temperature task is low priority and this V control task is high priority. Suppose if after reading one temperature, if this task is called, then what happens? Again, suppose if at previous time it is 70-70. After some time it is 71-71. But here 71 is updated to temperatures 0, but 71 is not updated to temperatures of 1. So because in between this task is called. So then what happens? Again you will get the problem, that is temperatures of 0 will be 71 and temperatures of 1 will be the previous value, that is 70. So then what happens? Here it will show that the temperatures are different. But at time t, both are 70. At time t2, both are 71. But it has not updated the temperatures of 1 because in between this task has been called. So because this is the shared data, so that's why we got that problem. So how we can solve that problem is, again you can use the semaphore. You can use the semaphore in this example also. So here we are giving the priorities. For read task you are giving 11, that is low priority, and for control task, that is this control task, you are giving high priority, that is 12. So this is stack size and you are using the read and control for this two tasks, and also you are using the high temperatures of 2. This data is being used by these two tasks. So here we are using the semaphore. So here here what you will do is, in the main function, first you will OS init function will be called, and next immediately you should OS create task is created, and then OS first of all the both the task has been created, that is V read temperatures task is created, and then V control task is also created. Those two tasks are created, and then you will start your RTOS. So here how we are solving the problem of this shared data is, so this is OS-SEM-PEND. OS-SEM-PEND is a this is the function for getting the semaphore. So it will be waiting for the semaphore. And similarly OS-SEM-POST. So already I told that you can use different words, give, take, and pend, post. Like this you can use different words that depends upon the different vendors of your RTOS. So so here this is for taking the semaphore, and this is the function for releasing the semaphore. Similarly, so once the semaphore has been taken by this task, in between these two, so here also it is asking for the semaphore. So if it didn't get the semaphore, means what? Again, the control will come here, and this high temperatures of 1 will be updated, and then it will release the semaphore. After releasing the semaphore only, you can get this V control task can get the semaphore. So then what happens? So both the temperatures you will get at time T2. So both will be 71, 71. So that's why both the temperatures will be equal. So then after completing this checking, so we will release the semaphore. So this is how you can solve the problem in the application nuclear reactor. And also if you see here, you can initialize the semaphores like this, OS-SEM-PEND. So, and this is this is the semaphore, and wait forever means it will be, suppose if you didn't get the semaphore means it will be blocked. Wait forever means it will be blocked until it gets the semaphore. So this is how you can initialize the semaphores. So this is how you will initialize the semaphores, and how you can solve the problem of shared data in the nuclear reactor application. So now we will see how the reentrancy and semaphore how it will work. So for example, if you in the previous session already I have explained the same example. So you can go through that example once. So there we got the problem of, suppose here you are incrementing the C errors. C errors, the initial value is 5. For example, assume that the value is 5. The value is 5. So then what happens? So first, suppose if task 1 is called, so then 5 plus this is added, and again the added value is again saved in C errors. So what happens? 5 plus 9 means the value will be 14. So again after task 2 is called. So now the C errors value, because it is declared it as static int. So now the value will be 14. So 14 plus again 11. So that means the value will be 25. But in the previous session already we have explained this example in detail. So there we got the answer as only 14 because we got the problem of switching of RTOS between the task. So that's why we got that problem. So we got the answer, wrong answer. So that can be solved by using this. You can use the take semaphore and release semaphore. NU underscore obtain underscore semaphore. So this is taking the semaphore and this is the releasing the semaphore. So in between, so this statement is given between this take and release semaphore. So that's why so even though this is converted into more number of assembly language instructions also, it cannot be interrupted in between because here you are using the semaphore. So then you will get the this particular instruction will be executed correctly even though it is converted into more number of assembly level language instructions also. So then now what happens? This function will become reentrant function because you are getting the correct answer and it is not violating any of the rules of the reentrancy. So that's why this function will become reentrant function. So you can also solve the problem by that reentrancy. How you can make it is by using the semaphores. So finally, in the summary, we have seen the different how to solve the in different applications, how to solve the shared data problem in different applications by using semaphores. So if you like my video, please like, share, and subscribe to our channel. Thank you.